Road to Olympiad.
Welcome to RTO. Consider the following problems. Let AB and C be the interior angles of an acute angle triangles. Prove that sine of A plus sine of B plus sine of C is greater than cosine of A plus cosine of B plus cosine of C is greater than 1. Sine of x is indeed greater than cosine of x for acute angle x is greater than pi out of 4. But is the sum of sine generally greater than the sum of cosine? To prove this inequality, we are going to split it into two parts. First, the sum of sine is greater than the sum of cosine. And then, the sum of cosine is greater than 1. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that since A, B, and C are acute, we have C is less than pi out of 2. Then we have A plus B is equal to pi minus C, which is greater than pi minus pi out of 2, or simply pi out of 2. This gives us the inequality A is greater than pi out of 2 minus B. Since both A and B are less than pi out of 2, we have pi out of 2 minus B must be positive, as well as both A and pi out of 2 minus B must be less than pi out of 2. Recall that the sine function is increasing in the range of 0 to pi out of 2, so we have sine of A must be greater than sine of pi out of 2 minus B, where sine of pi out of 2 minus B is simply equal to cosine of B. Here, we get sine of A is greater than cosine of B. Repeating the same process, we are able to get sine of B is greater than cosine of C, and sine of C is greater than cosine of A, where when we add up the three inequalities, we obtain sine of A plus sine of B plus sine of C is greater than cosine of A plus cosine of B plus cosine of C. For the second part, to show that cosine of A plus cosine of B plus cosine of C is greater than 1, we start by considering the sum cosine of A plus cosine of B plus cosine of C, which can be written as cosine of A plus cosine of B plus cosine of pi minus A plus B. By using the sum to product formula for trigonometry, we can write cosine of A plus cosine of B as 2 times cosine of A plus B the whole thing over 2 times cosine of A minus B the whole thing over 2. And by using the double angle formula, we can also write cosine of A plus B into 2 cosine square of A plus B the whole thing over 2 minus 1. Factorizing the 2 cosine A plus B the whole thing over 2, we have this one. Notice that A plus B is equal to pi minus C. So cosine of pi minus C the whole thing out of 2, or cosine pi out of 2 minus C out of 2 is simply equal to sine of C out of 2. Also, by using the sum to product formula again for the expression in the brackets, we get negative 2 sine of A out of 2 times sine of negative B out of 2, where sine of negative B out of 2 is simply equal to negative sine of B out of 2. Expanding the bracket, we get 4 times sine of A out of 2 times sine of B out of 2 times sine of C out of 2 plus 1, and this is clearly greater than 1 for acute angle A, B, and C, as sine of A out of 2, sine of B out of 2, and sine of C out of 2 are all positive in these situations. Combining both the inequalities, we have proven that sine of A plus sine of B plus sine of C is greater than cosine of A plus cosine of B plus cosine of C is greater than 1. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video. And if you haven't subscribed yet, consider subscribing. These will really help us out. Anyway, see you in the next video. Thank you.